Hello. These are your 2.5 notes that we are looking at. We're going to talk about application of sets. And first, there's a hint. When drawing Venn diagrams, we generally start with the intersection of sets. So intersection of sets and work outward. I'm going to show you what the intersection of sets means when we do this first problem. So for each problem, draw a Venn diagram to answer the question, show all work. So you need to show everything that you're doing. So number one, the Greens are moving to Athens, Georgia. Their real estate agent located 77 houses listed for sale in the Athens area in their price range. Of these houses listed for sale, 47 had a finished basement, 52 had a 3-car garage, and 35 had a finished basement and a 3-car garage. So what we're going to do first is draw the Venn diagram. So what we have here is we have the two sets. We have the basement and we have the 3-car garage or finished basement. So I'm going to mark this as basement and this as garage. Now, this here is the intersection that what it's talking about. So intersection and work outward. And it of course depends on the problem if we can do that or not. But let's see what happens with this one. So there's 77 houses total. So that means that there are 77 houses in the universal set here. So 47 had a finished basement. What I'm going to do is I'm going to write the 47 right here next to the basement for now. 52 had a 3-car garage, so there's 52. And then 35 had a finished basement and a 3-car garage. So again, this is the and, it is the intersection of these two. So I'm going to write 35 in the middle here. And now we can start doing the calculations. So we know that there's 47 basements. Well, 47 houses with finished basements. 35 of them is already here with the 3-car garage. So what we're going to do is we're going to take those 35 away. So we're subtracting. And we get 12. Next, we're going to do the same thing for the garage. So we have 52 altogether, but 35 of them are already counted here in the intersection. So we're going to subtract 52 minus 35, and that is 17. This is how you show your work. You're showing the subtraction over here. So we're going to answer the questions. How many had a finished basement but not a 3-car garage? So a finished basement but not the garage. That would be this number only that's in the basement, which is 12. How many had a 3-car garage but not a finished basement? So a 3-car garage but not a finished basement. That would be 17. This part here. How many had either a finished basement or a 3-car garage? Or, so we are looking at either or, the union of these. Okay, so here's the thing. If we're only looking at that word or, so how many had a finished basement or a 3-car garage? There's a difference. So if we're talking about just the or and ignoring this word here, that would be the union. Now, we have the word either here, So either or, which means that either a finished basement or a 3-car garage, but not both. So that means that we are taking the 12 and the 17. We're taking the 12 plus 17, and we get 29. Either or, not both, either or. Okay, next let's look at number 2. So we have Dunkin' Donuts collected the following information regarding purchases from 100 of its customers. 65 purchased coffee, 41 donuts, and 22 both coffee and donuts. So again, we're going to start with the Venn diagram. So we have coffee and we have donuts. We have 100 altogether, so 100 customers goes up here. That's in the universal set. So 65 purchased coffee. I'm going to write the 65 next to the coffee. We have 41 purchased donuts. And 22 purchased both coffee and donuts. So 22 would be the intersection over here. And again, what we're going to do is we're going to take that 22 away from the 65 and the 41 because it's already in the middle here. So 65 minus 22, that equals 43. Same thing with the donuts. 41 minus 22, subtracting that, this equals 19. And now, actually, what we did not do with this one, what we can do is we can double check by making sure that we have 100 here. So 43 plus 22 plus 19. So right now, if you look at this number, we get 43, 22 plus 19. We have 60, 70, 81, 84. Let's take out the calculator so I'm not making a mistake. So 43 plus 22 plus 19 equals 84. So this number is only 84 and not the 100. We had 100 customers that were interviewed. So what happened to the ones in between? So that would be 100 minus 84. 16. Well, the 16, it did not buy coffee or donuts, so that would be in the universal set here. So, how many purchased only coffee? Only coffee would be this number here because it is not in the intersection. 43. Only coffee. How many purchased only donuts? Well, that would be this number here because that is only donuts. How many did not purchase either of these items? So there's the did not purchase. Well, that's the number that's outside here, which is 16. Okay, so now, so both of these were with just, were with 2 sets. This next one here is going to have 3 sets. So we have a survey of 92 resorts. where 27 had a spa, 55 had a fitness center, 38 had a children's club, 13 had a spa and a fitness center, 10 had a spa and a children's club, 19 had a fitness center and a children's club, and 7 had all three features. So we need to draw, and I'm going to try to get a little bit bigger so that I've got enough room here. So again, we're drawing the same 3 circles here. And now I'm going to put spa here, fitness center here, and what was our children's club? I'm just going to do club over here in this third one. So altogether, we had 92 resorts. So this is 92, the universal set. Then we're going to start putting these in. So 27 had a spa, so 27 goes here. 55 had a fitness center. 55. 38 had a children's club. So 38 goes here. And why am I putting them outside? Because 38 is this whole circle here. But we have 1, 2, 3, 4 sections in it. We don't know yet where these are going to go. So let's move forward. So we did this, this, and this. Next, what it said over here, generally start with the intersection of the sets and I work outward. So let's go ahead and do that. So intersection, which is actually this part here, that would be the intersection of all three, would mean that the resort had a spa, fitness center, and a club, right? Because it's all of those circles. Well, here we have 7 had all three features. So we're going to put the 7 in. Now, next, we know that 13 had a spa and a fitness center, and I'm going to put the 13 actually here. 10 had a spa and a children's club. That's going to go over here. It's kind of because it's going to be over here in this whole thing, but we already have a number here. Next, 19 had a fitness center and a children's club. So the 19 again goes over here. So now we can start figuring out, because we do have that 7 in the middle. So this 13 is this whole thing here. So we're going to have to take that 7 away. So 13 minus 7 equals 6. Ten is this whole thing here. So 10 minus 7, we're subtracting this from the 10 because we don't want to count it twice, equals 3. This whole thing here, we have the 19, and we're again subtracting this 7 because it's part of it and we don't want to count it twice, equals 12. So now we can start calculating these parts here. We know that the spa has 27, or there are 27 that have the spa, I should say. We're going to subtract all of these because, again, we don't want to count them twice. These belong to the spa circle. If you look at it, all of them have a spa. 27 minus 6 minus 7 minus 3. 27 minus 7 is a 20, minus 9 is 11. So now if we add all these, 3 plus 7 is 10, plus 6 is 16, plus 11 is 27. That should add up to this. Or we've made a mistake. Next, we're going to look at the 55 fitness centers. So 55, again, The fitness centers are all these, and the 55 counts all of them. So we want to subtract these. So minus 6 minus 7 minus 12 equals 30. And then this children's club circle, again, we have all these. We have 38. And then we're going to subtract 3, 7, and 12. And when we do that, we get 16. Okay. So let's start answering questions. How many of the resorts surveyed had only a spa? Only a spa would be this number here because it's not intersecting with any of the other circles. It's only where the spa is. So that would be 11. Exactly one of these features. So that would mean spa only, 11, plus fitness center, only the fitness center, plus 30, plus only the children's club, 16. So this equals 57. 11 plus 30 plus 16. So exactly 1. So exactly 1 are all of these, where they are not intersecting with the other circles. C, at least 1. At least 1 of these features. So at least 1 means this has 1, this has 2 because it's overlapping with both of these. This has 3. This has 2, 2, 1, and 1. So we're going to add all these together. So 11 plus 6 plus 30 plus 3 plus 7 plus 12 plus 16. And I did not use my colors like I did in the previous one. So 11 plus 6 plus 30 plus 3 plus 7 plus 12 plus 16. 85. Next one, exactly 2 of these features. Exactly 2. So not 1 and not 3, exactly 2. So exactly 2 would be this, this, and this because they are overlapping 2 of them. So 6 plus 3 plus 12, and that equals 21. Well, none of these features. Well, we did not actually add all these up and figure out what, well, in a way we did, if we look at this. When we did at least one of these features, the C, this 85, notice we added all of these. So basically we need to take that 85 and subtract it from the 92. So 92 was all the resorts, and 85 was resorts with at least one of these features. At least one. So 92 minus 85, and that's a 7. Okay, let's move on to the next one. Now, I recommend that you try this one on your own. Stop the video and or pause the video and then play it again once you've done it, or if you get stuck, and see what happens. So I'm going to move on. Panera Bread compiled the following information regarding 30 of its employees. The following was determined: 8 cooked food, 9 washed dishes, 18 operated the cash register. So that's our Venn diagram. Again, we have the 3. We have cooked food, washed dishes, and operated cash register. So food, dishes, and the register, cash register. So we have altogether 30. Now, 8 cooked food. So 8 goes here. 9 washed dishes. 9. 18 operated the cash register. 18 goes down here. 4 cooked food and washed dishes. So cooked food and washed dishes. Let's put 4 in here. Cooked food and washed dishes. 5 washed dishes and operated the cash register. So 5 goes in here. 3 cooked food and operated the cash register. So cooked food and operated the cash register. 3. 2 did all 3 jobs. So again, 2 did all 3 jobs. So the 2 goes in the middle here, in the intersection of all 3 circles. So now we need to again start figuring out these other numbers and what we're, how many we have. Well, of course, again, we're starting with that 2 since we know it, and we're going to go outward. So we know that this whole thing is going to be 4, but we already used that 2. So this is going to be 4 minus 2, which is 2. Same thing here with this one. We have 3, and we've already used the 2, so we have 1 left. Over here, we have 5, and we've already used the 2, so we have 3 left. So now we're going to start figuring out the ones that only did the 1 job. Those were the ones who did 2 jobs. So who cooked food? We have 8 who cooked food, so 8. And we have to subtract all these because they're already being used. So 8 minus 1 minus 2 minus 2, which is 3. Next, we're going to look at washing dishes. So again, we have the 9 total here. So we're going to subtract the ones that are already ones that have already been used. So 2 minus 2 minus 3. 4, 7, 9 minus 7 is 2. And then with the cash register, the same thing. We have 18 as the total for this circle here. 18, but we've already used these. So 18 minus 1 minus 2 minus 3. That's 5, 6. This is 12. So, how many of the employees only cooked food? Well, that's this one here. That would be 3. Only operated the cash register. It would be this one here because that's the only one. 12. Washed dishes or operated the cash register but did not cook food. So washed dishes or operated the cash register but did not cook food. So we're going to take all of those away and we want to add these 3. Everybody who cooked food we're going to take away. So 12 plus 3 plus 2, which is 17. D, did at least 2 of these jobs. Did at least 2. So at least 2 means that they have to be in these intersections, because these are the ones that did only 1. So 1 plus 2 plus 2 plus 3, which equals 8. Okay, I believe we have one more. And this actually is a bonus one. So let's see how that goes. So when the Montesano family members discussed where their annual reunion should take place, they found that all of the family members, 8 would not go to the park, 7 would not go to the beach, 11 would not go to the family cottage. So there's your 3 circles for the Venn diagram. So we have park, we have beach, and we have cottage. And now notice what these say. Would not go, not go, not go. So 8 of those did not want to go to park. 7 would not want to go to beach, and then 11 would not go to the family cottage. So let's look at the next ones. 3 would go to neither a park nor a beach. Again, neither nor. 4 would go to neither a beach nor the family cottage. 6 would go to neither a park nor the family cottage. 2 would not go to a park or a beach or to the family cottage. So what would this 2 be? 2 would not go to a park, a beach, or a family cottage. So basically we would cover all these 3 circles. So the 2 means that they're in this universal set. They don't want to go anywhere of these 3. And then we would have 1 would go to all 3 places. So that 1, of course, goes in the middle because that 1 would go to all 3 places. So that's the intersection. Okay, so let's look at now what we have here. So if we kind of switch this to the opposite, so it says 8 would not go to a park. Well, would those 8 go to the beach and the family cottage? So this one would go to the park, beach, or cottage. 7 would not go to a beach, so park or cottage. 11 would not go to the family cottage, so beach or park. Right? 3 would go to neither a park nor a beach. So those 3 want to go to that third place, park or beach, which means the cottage. 4 would go to neither a beach nor the family cottage. So neither a beach or a family cottage, meaning that 4 would go to a park. 6 would go to neither a park nor the family cottage. So that would be a beach. Okay, so now since 8 would not go to a park, so we want to rule out the park, but they would go to beach or cottage. The 8 actually goes in here because it could be either or. 7 would not go to a beach, so we're going to cover the beach and either park or cottage, or they would go either one. So the 7 goes here. 11 would not go to the family cottage, So we're going to cover the family cottage, but they would go to the park or the beach. So 11 goes in here. Now, it's asking what is the total number of family members. The total number of family members we're going to add up. 4 plus 11 plus 6. And we have to remember these two who didn't want to go in any of these three places. 7, 1, 8, and 3. 4 plus 11 plus 6 plus 2 plus 7 plus 1 plus 8 plus 3 is 42. So they have 42 family members. Remember, again, this is a bonus one, and that is why we have, we have the negatives, so it is a little bit trickier. But if you understood it, awesome. If you're not so sure, concentrate on the first 4. Okay, this is it for this one. Again, please do not hesitate to ask any questions from me. Bye.